Hello, so this is a calculus video that I'm making from Houghton College. Not that I'm not a math professor. Don't try this at home, but I did stay at a Holiday Inn Express once. That's not important right now. I am following James Stewart in his Calculus 6 edition, and this chapter 7. There's another version of Stewart's work, early transcendentals or something like that. I haven't found this chapter, or it's not in the same place, but I'm doing it anyway because this is the book I have. And so this section is the second section of the 7th chapter of this edition on exponential functions and their derivatives. In this particular video, I just want to introduce or probably remind you of the exponential function. Now, the exponential function is a number raised to a power, like 2 to the x. Don't confuse this with the power function. The power function is a variable raised to a power, like a number, 2, 3, 4, 5. This is switched, right? This is a number. The exponential function is a number raised to a power, okay? A number raised to a power. So let's review a few things that you should know from some time ago, I would imagine, but if you've forgotten, any number raised to the 0th power equals 1. So remember that. That was great. I remember that. I remember many old days when we learned that. That was wonderful. Also remember that if something is raised to a negative power, that's basically saying 1 over that number to the power. So, sorry, this should be, yeah. So a to the negative n. Sorry, let's just fix that right now. There we go. A to the negative n is the same as 1 over a to the n. So a negative power means flip it good. Okay, so also remember that a to the p over q is the same as the qth root of a to the p, or the qth root of a raised to the p power. You can do it either way. But basically, the p is a power and the q is a root in that particular format. So these are things that you learned somewhere, probably in pre-calc, before you even got to calculus. Okay, so in general, now basically a to the x, we can conceptualize it as the limit of a to the r as r approaches x. This seems pretty commonsensical, as many things do in math. Of course, when you're a real mathematician, there are all kinds of caveats and, well, when blah 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 blah. But I'm not making these videos for the person who just thrives on the delta, epsilon delta stuff. I'm doing these videos for the person who maybe struggles a little. So this is pretty easy, that you simply replace the r with x, and I'm also making them for myself. Let's be honest, this is more for myself than for anybody else. But this makes sense. Limit as r approaches x, it becomes a to the x. Duh, and again, we're assuming that r is a rational number. Okay, why does Strong give you this? Part of why he gives you this is because if you read the section, he's asked, questions like, can you take something to the square root? Like, can you do a to the square root of 2? And the answer is, of course, that you can. And if we had to figure this out, we can use the squeeze theorem, do the limit on the one side, so square root of 2 would be 1.414, right? So it's somewhere in between a to the 1.4 power and a to the 1.5 power. Well, how do you do 1.5 power? Well, you can use these kinds of rules here to approximate a a to the 1.7 or a to the 1.6. And so then by using this kind of a limit concept, we can figure out, by using more and more decimal points, we can squeeze in, of course you use a calculator these days, but we can squeeze into what a to the square root of 3 power would actually be by looking at the things on each side of it and kind of narrowing in on it. Okay, so here's what we find out in general. How does the exponential function basically behave if you were to graph it? Well, if a is in, and by the way, all of this section assumes that a is 0 or well, no, that a is positive. So a is greater than 0 is an assumption of this entire section. I assume at some point we'll explore what it might mean for a to be negative. That's my assumption. But this section is not about a as a negative number. This entire section assumes that a is positive. So if a is in between 0 and 1, the function's going to decrease. So it's going to go down. If it's 1/2 to the x power, then it's going to be a decreasing function. If a equals 1, then it's just the number, right? It's going to be horizontal. It's going to be constant. And it's going to be basically, since 1 to any power is 1, it's just going to be a line, y equals 1, basically, parallel. Now, if a is greater than 1, then the function is going to increase. And by the way, probably the way this is videoing and the way it appears is the opposite. So let me, the hand motions I just did are exactly reversed, right? Let me see if I can do this. So it's going to decrease. Is that right? It should be the mirror image of what I'm doing right now. It's going to decrease if a is in between 0 and 1. It's going to be horizontal if it's a equals 1, and then it's going to, I think it's going to increase if a is greater than 1. Okay, so that's the way this exponential function generally behaves. And the bigger the a, the steeper the increase, the faster more rapidly it increases, the bigger that a is. So the bigger they are, the closer they meet to infinity. Okay, so this is kind of how the exponential function behaves. Laws of exponents, again, nothing here is going to be particularly new if you remember your pre-calculus. So a to the x plus y is a to the x times a to the y. Okay, remember that rule from a long time ago in a faraway place. A to the x minus y is going to be a to the x divided by a to the y, because remember, to the minus y puts it in the bottom, right? A. And then this is going to be, so if it's a plus, then you multiply it by each other, but in this kind of way. But if it's x to the y, then you multiply them by each other. Let me do it the other way around. So when you have this kind of a situation, you add the exponents. But when you have this kind of situation, it's raising this to that power, and you multiply the exponents. And then lastly, it distributes in this case. So these are called the laws of exponents. They should be fairly familiar to you from your pre-calculus days, maybe your Algebra 2 days even. I don't remember. I don't know how far you got in Algebra 2. Some important limits as we finish out this video at the beginning of this section. I'm dividing this section into 2 parts. So if a is greater than 1, then the limit as x approaches infinity of a to the x is going to be infinity. That makes sense, right? Because this is going to be bigger and bigger and bigger and bigger and bigger and bigger and bigger, so it's going to be infinity. By the opposite, however, as it approaches negative infinity, so we're now, let me see if I can do this right. This end, so it goes like this. So as we go to this end, it's going to approach 0. It's never going to reach it, I don't think. But as it goes to negative infinity, the limit approaches 0. Okay, now if a is in between these two, remember, if a equals 1, it's horizontal at y equals 1. But if a is in between 0 and 1, then it's going to be the opposite of what we just said. Then the limit, let me see if I can do this right. It's like this, isn't it? Yeah, should be the mirror image of what I'm doing. Look at the chart in the book to make sure I'm right. I think this is right. So as it goes toward infinity, it's going to approach 0 because it's decreasing. The function of a to the x is decreasing in between here. On the other hand, as it approaches negative infinity, remember it's decreasing. So as it approaches negative infinity, it's going to approach infinity. So exactly the opposite. So some important limits relating to the exponential function a to the x. Well, do you have a taste of it? We are going to look at derivatives of exponential functions in the next video. So this has been kind of an introduction to the exponential function. By the way, we're going to be doing two different versions of this. Stuart gives one version that is a little bit more simple. That's the series you're in now. And then he goes back and he gives a more mathematically pleasing introduction to it. So these 3 videos and then the 3 videos after them will look at the same material, but from a more my brain hurts function, which is what this one is, and then a little bit later from I'm a true mathematician, which is not me, but we'll do it. We'll do those videos. It's coming on up.